So we're given the graph of f of x, and we're going to sketch the graph of y equals 4f of negative 0.5x. So what we would say right now, a couple things to notice, is the type of notation that we're dealing with right here is called function notation. They just call this f of x, which means generally they're just saying it's a function. We can find out the equation, and we're going to do that later. But right now, it's just could be any shape, even one you don't know the equation of. And then they give you in function notation some changes. So first of all, we're going to label all the changes. What is that for? It's outside, so it's vertical. And it would be a vertical stretch. Mathematically, we're going to multiply our y values by 4. Then inside, first we have a negative. That's inside horizontal. A negative is always a reflection. And the 0.5 is horizontal as well. And remember that x's are liars. So we're not going to multiply by 1/2. We're going to multiply by 2, which makes this a stretch. So multiplying by -1 and multiplying by 2, we can put those together and just say the horizontal reflection and horizontal stretch together can be shown by just multiplying by -2. So what does that mean? Well, if we took our original graph, it looks like we have 3 easy points here to see. We have -2, 0. We have -1, 1, and we have 2, 2. And then those points are changing, and above this arrow, I like to write what's going to happen. Now, I usually write the x1 first. We're multiplying x by 2 and y by 4, just because your x coordinate is first and your y coordinate second. So I'm giving myself instructions. What should I do to these points? I'm going to take the x coordinate and I'm going to multiply it by -2, which is going to give me 4. I'm going to take my y coordinate and multiply it by 4, which stays at 0. Same thing here. My x coordinate multiplied by -2 becomes +2, and y coordinate multiplied by 4, 1 times 4, will become 4. And finally, the last point, the 2 will become -4, and this 2 and multiplied by 4 becomes 8. So I can put those points on my graph. I have this point here, 4, 0, 2, 4, which is there, and oh my goodness, -4, 8, that's like up over there, off the graph. Now, what's going to happen is sometimes you're going to get those 3 points and you're still going to be a little bit perplexed and say, well, how should I draw the final graph? Some other things that can be very helpful. As far as the red graph goes, can you see that this is a super important point? Because that's where it starts. Okay, that was this one. What happened to that one? It changed to this one. So I'm like, oh, that's my starting point. So when I go to graph it, I'm going to start here and go through these points this way. A couple of other things I'm going to check. Did you notice that the first one was like square root graph in its shape? Does my blue one have that same kind of square root graph shape? Okay. Go through mentally and say, does it look like it's been stretched vertically? Do I have the right reflection? Does it look like it's been reflected horizontally? Yes, because my new one's going in the opposite direction. And then it's also been stretched horizontally. Sometimes when you have vertical stretches and horizontal stretches, it's hard to say for sure if you can see that they've happened. But generally here with the reflection going the other way, the shape seems to be right. Some sort of stretch has happened. This looks good. Okay? And of course it says state domain and range of each. The original one, the domain, the x values were bigger than or equal to -2, and my range was bigger than or equal to 0. And then on my blue one, my x values are now less than or equal to 4. My y values are still bigger than or equal to 0. So reread the question, we've done the sketch, we've stated the domain and range. Okay? Now, I'm going to do a little extra in this question because one of the things that's sometimes confusing but can often be, once you get it, be very, very helpful is the ability to flip between function notation and explicit notation. Okay? So as far as explicit notation goes, you should be able to recognize this graph. Can you see that the red graph originally is a square root graph that has been moved 2 to the left? And so if we were writing the explicit equation, x's are liars, that would be the square root of x plus 2. Next, we want to find the equation, the actual equation for the blue one. In function notation, we were told the blue one was this. So how do we change that function notation back into the explicit notation? Okay. First of all, a couple of things. Wherever you have f of x, you get to replace it with the square root of x plus 2. Does that make sense? And wherever you have something inside, a little purple here, like if I have an x something inside, that replaces wherever the x is. So if I ask you what's f of 3, you'd be like, oh, I just plug in 3 for x. Okay? And it's amazing that as students, we have no problem if the teacher says, find f of 5. Oh, plug in 5 for x. But as soon as I say, find f of negative 0.5x and put another x in there, it's like, oh my goodness. Life just got difficult, even though it's the same idea. So here, in my blue equation, first of all, that 4 is outside the function. It stays outside the function. Now I have this, which I'm going to put it, right? This is green box around it. That's f of something. This gets replaced with a square root. Oops, color-coded. Square root of, and it's supposed to be x plus 2, but then inside, what do I have instead of x? I have negative 0.5x plus 2. Now currently, it was easy to graph it in the function notation. If I gave you this question, just like this, and asked you to sketch it, we would currently have some difficulties. There's some stuff that we still need to kind of learn in that format, which we're going to get to. But this right now would be a little bit difficult. The question is, could you change it back into function notation? Could you recognize the 4's out in front and say, oh, I kind of like this as an x plus 2 and switch it back and forth? Sometimes it's hard to switch from an explicit equation back into function notation. Questions you can do for practice on this one are 7, 9, and 10.